Hello. The most exciting feature of our SmartBench Pro Plus is YetiPilot. So in this video, I'm going to explain to you what YetiPilot actually is. I'm going to do a live cut with you, and throughout that demonstration, I'm also going to give you a technical commentary as to what's going on. YetiPilot is another world first from us here at YetiTool, and we're really excited about that. And for you to understand it, you only need to know one thing. YetiPilot listens to the tool. And by listening and getting that feedback from the tool, it's then able to be even smarter. So if it sees that the spindle is under low load, then it can speed up. But similarly, if it sees that the spindle is under high load, then it can slow the job down. YetiPilot relies on our new SC2 spindle, which we spent a couple of years developing with our spindle partners Mafel, and the SC2 outputs load data 50 times a second, and YetiPilot makes adjustments from there. Technically speaking, this is adaptive feed rate control, and because it's all done internally within the machine automatically, it can make those adjustments way quicker than a human operator would be able to do. And the benefits that come with that are really big. So if you're a new user and you're not entirely sure what your feeds and speeds need to be, then YetiPilot will compensate and make sure that it looks after the machine itself. If you're an experienced user, what you'll find is that YetiPilot will also go some way to optimizing your job by accelerating in areas where it thinks it can push harder. And finally, because the power is more balanced, there's much less spiking going on, that's a much better condition for things like tool wear in the spindle and in the tool itself. But that's enough chat. Let's actually do a cut. And while it's working, I can show you what's actually happening. Our job will extend the full width of the x-axis in 18mm MDF. We'll be working from left to right, starting with a detail here, where I'm speccing diameter 6 as a reminder as to the diameter of our cutter, followed by 2 pockets of different depths, another detail here to remind me that it's a 2mm and 8mm depth, followed by a series of trenches ranging from 2 to 8mm deep, followed by a logo of YetiPilot to see how all of that comes together. And finally, we'll be cutting out around the whole series of shapes to illustrate a part off, and you'll note some castellations on that top edge. Also, there's a tab at the end and 2 at the bottom in the 3D profile shape. For this cut, I'll be using a 6mm down cutter. It's had some use, so let's put it under the scope here and check it out. There's a bit of residue on the flutes, and critically, we can see some wear underneath the cutting edge there. So this is a real-world test for YetiPilot. And all that remains is we need to get this into our SC2 spindle, put it onto our Pro Plus, and let's get cutting. Before the cut, let me introduce you to my screen here. We've got an aerial view of SmartBench Precision Pro Plus. Then we've got a really nice shot of the cut. And top right up here, we've got a visual map as to which part of the job SmartBench is working on. And then over here to the left, we've got the data. On top here, we have the depth of the cut. So if you see anything below 0, that's how far into the material it's cutting. This next item, feed override, is the most important value on this screen. And that is what YetiPilot is changing. Feed is how quickly SmartBench moves the cutter in the XY plane. And feed override is a way of slowing the machine down or speeding it up. So if you see 50%, you know it's only allowed to go at half speed. If you see 200%, you know SmartBench is allowing it to go at double the speed through the material. And actual feed is the number of millimeters per minute that the cutter is moving. Okay, let's go. So the tool's coming into the job, doing a 1mm depth on just a small detail. And as soon as it's finished that detail, it's going to go into the first pocket, which you can see is 8mm deep. Now the feed override immediately has dived to 60% on that first pass. And that was a full face contact. So now it's doing a step over. You can see that that feed override is rising because it can see that the load on the spindle has lessened and it's able to now increase. Now it's still an 8mm depth cut, but it seems quite happy to be moving at 130% there. The next pocket is much shallower, it's only 2mm deep, and you can see immediately YetiPilot is saying, come on, let's go quicker, and it's overriding that feed to a full 200%. On to the next feature now, and this is a detail cut again. This is just telling me that it's 8mm deep on the deepest parts with an arrow, and here comes the number 2, again 200%. The next features are just trenches, okay, one line at a certain depth. We just did 2, now we're going to do 3. Again, it's fine, 200 is the highest it can go, so it's just staying at 2, it's still not stressed. Even at 4mm depth, we're finding that the tool is not stressed at all. The next cutting depth is 6mm, and it's starting to see a bit of load there, so it is slowing down. And then finally, our cutting depth in this trench will be 8mm, and again, that's a lot more load, so it's really dialing that feedback to, seems comfortable, about 70% there. On to the logo now, and this is really a true test as to putting all of these features together. You'll see that that depth, again, it's an 8mm single cut all the way through, and it seems to have found its happy place at about 100%. Again, we can see YetiPilot reining back the feed where necessary to keep the spindle happy. To keep this video short, we'll just skip ahead to the next feature. This has been a deep cut for the Yeti part of the logo, so I'm just going back here and cleaning up those faces. What you'll notice is that for the shortest sections of tool pathing, you'll notice the actual feed never actually gets to the top speed. And that is quite simply because it's mostly accelerating and then having to decelerate quite quickly. It just doesn't have enough distance to reach that top speed. And therefore, because of that, you won't see much adjustment there to that feed override. Moving on now to the second part of the logo, I've decided to only go as deep as 2mm, and that's much less load on the tool. But again, you can see that the feed override is increasing. It won't go immediately to 200% because, as mentioned previously, if it's only doing short sections, then it's not actually able to achieve maximum speed because it's accelerating and then decelerating again. So it might be a little while before it finds a segment where it can truly stretch its legs, at which point we would see that percentage go up. Again, let's skip ahead to the next feature. All right, so the logo and the features have been done. We'll do that final part off, and the first depth will be 4mm. We can see some castellations here. I've just put that into the file there to illustrate some features that a typical profile cut would be. and its second pass will dive to a full 8mm depth. This will be the last depth, and at some stage we're going to see a couple of tabs. They are 3D profile tabs, so we'll see the Z lift. There it is, there's one of them. Fantastic shot from cutter cam here, collecting all that dust. Second tab coming up, and then there's 2 more tabs on the bottom. You'll notice now that that autopilot is all the way up at 200%. It's absolutely flying down that home straight, doing a fantastic job of the part off there. So we've seen the full range, and the final action in this job is to go back and do the whole thing again at the same 8mm depth. And there's a couple of reasons for this. The first one is to evacuate all of the dust, make sure we've collected everything, because that trench is quite deep. So running the tool is an easy way of collecting all of that dust. But it's also very good practice if you're after an accurate feature, because you know, as good as YetiPilot is, it's not going to make tool deflection go away. So this final extra pass just dials that accuracy back in, and we'll have a look at that next. The last thing to check is our accuracy. So looking at the cut file, we should expect a width of 103.65mm. So looking at various widths along the length of the job, I'm really pleased to see that this is so close to nominal, certainly within tolerance. So YetiPilot's done a great job there with the assistance of a final cut pass just to clean up any tool flex. Well, I hope you enjoyed that. And if you wanted to cut the file to see for yourself, there's a link to the job file and the VCarve source file in the description below. Some notes about what YetiPilot can and can't do. We've developed YetiPilot to be really good at profiles and pockets, as shown in the demo cut here. And when you enable YetiPilot, it will even recommend to you optimal step downs. But if you're running a job file with 3D sculpture in it, it won't be able to optimize that yet. Also, YetiPilot can't overcome tool deflection. So if your application is sensitive to tool deflection, it's worth running a final finishing pass as we did in the demo cut to bring it into tolerance. This really is taking automation to the next level. So for new users, YetiPilot's going to be looking after the machine more. For pro users, it's going to be optimizing jobs where it can. And with more management on power, we'll be seeing an improvement in wear on spindle and tooling. Thanks a lot for watching.